Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to solve systems of equations algebraically using the elimination method. How are we learning it? Through the systems of equations using Elimination Part IV notes and the systems of equations using Elimination Part IV assignment. When can we use this information? To find economic solutions to financial problems such as income versus expenses and supply versus demand. How do you know you learned it? By getting a score of 4 on the systems of equations using Elimination Part IV assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the solving systems of equations using Elimination Part IV notes, and then I'll give you time to complete the solving systems of equations using Elimination Part IV assignment. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Systems of Linear Equations study guide and any incomplete assignments that you may have. Let's take a look now at the solving systems of equations using Elimination Part IV notes. The notes begin with the learning goals and success criteria. Now let's take a look at how we can graph systems of linear equations. So all this really means is we're going to graph both of these lines at the same time. So on the first one, we'll go ahead and graph this. So we're going to plot our y-intercept, which is -2. So we're going to go down 2 and plot our point. And the slope is 1/3. So we're going to go up 1 to the right 3, plot our point, and connect the dots. So just like we did earlier, that's the same thing we're going to do now. Now, we're just going to plot the second line on the same graph. So my y-intercept for this one is 3. So I'm going to go up 3 and plot my point. And my slope is -1/2. So I'm going to go down 1 to the right 2, connect the dots. And notice now I have a point where they intersect, which is right there. That is considered the solution to the system of equations. Now let's talk about how we can solve this without having to graph. So if we're given something like this, 3x minus 2y is equal to 24 and 3x plus 2y is equal to 12, we're going to go ahead and solve this using what we call elimination. So here are the steps. First step is we're going to check for opposite x values or y values. Now opposites mean they have the same integer but with opposite signs. So for instance, we have a +3 and a +3. Those are not opposites. We have a -2 and a +2. Those are opposites. So these two represent opposites. So if we have opposite x or y values, we're going to go ahead and add the equations together. So we're going to add the entire equation. So we'll add these up. So we add 3x plus 3x and we get 6x. -2y and 2y is equal to 0, right? So that's the elimination part. We eliminated the y's. And then 12 plus 24 is 36. So we end up with 3x is equal to 36. Now we're going to solve for x. So 6 is being multiplied by x, so I undo it by dividing. So we divide both sides by 6 and we get x is equal to 36 divided by 6 is 6. So that's x. Now we know the x coordinate of where they cross, but now we need to get the y coordinate. So we're going to plug 6 in for x into one of the two equations. It doesn't matter which equation you pick as long as you plug in x as being 6. So we'll go ahead and pick this one. We'll pick the first one. And we're going to plug 6 in where x is. So instead of being 3x minus 2y is equal to 24, it's going to be 3 times 6 minus 2y is equal to 24. So 3 times 6 is 18. So we get 18 minus 2y is equal to 24. We need to get rid of this 18. So we're going to subtract 18 to get rid of that. And we're left with -2y is equal to 24 minus 18 is 6. We'll divide both sides by -2 and we get y is equal to -3. Now let's take a look at another example. So we're going to check for opposite x values or y values. So we have a +1 and a -2. Well, they have opposite signs but not opposite values. We have a -1 and a -1. So again, we don't have opposite values. So if we don't have opposite values, we're in trouble. So what we need to do is we need to create opposite values. We need to multiply either one or both of the equations by some number to get opposite values. So in this case, the easiest looks like it might be the y's, because we could just multiply one of these by a -1 and that gives us a positive y and a negative y. But we could also do the x's. We could multiply this whole thing by 2. That gives us a positive 2x and a negative 2x. But we're going to go ahead and do the top one by negative 1. If we multiply the top one by negative 1, we get positive y and negative y. Now, here's the deal. Anytime we multiply this, we have to multiply everything. So that's the x's, the y's, and the constants. Everything's got to get multiplied. So when we do that, we get negative 1 times x is negative x. Negative 1 times negative y is positive y. And negative 1 times 11 is negative 11. So what we're left with now is negative x plus y is equal to negative 11. And the bottom one didn't change. So now, notice we have opposite x and y values. So now we just follow the steps we did previously. So then we're going to add the equations together. And we get negative x and negative 2x is negative 3x. These cancel out. And we get negative 11 plus negative 19 is negative 30. So we have negative 3x is equal to negative 30. Now we just solve. So we divide both sides by negative 3. And we get x is equal to negative 30 divided by negative 3 is positive 10. So there's our x value. Now we're going to plug that in to one of the equations and solve for the y value. So I'm going to go ahead and use my new equation. I can use the new equation or any of the two that I started with. I'm going to just use the new equation. That's fine. So I'm going to plug 10 in for x. So this is negative 10 plus y is equal to negative 11. I add 10 to both sides to get y by itself. And I get y is equal to negative 11 plus 10 is negative 1. So y is negative 1 and x is 10. Let's look at another example. We have 5x plus y is equal to 9 and 10x minus 7y is equal to negative 18. So again, check for opposites. Well, 5 and 10 are not opposites and 1 and negative 7 are not opposites. So I need to create opposites. So I could multiply this one here by negative 2. That would give me negative 10x and 10x. Or I could multiply it by 7, and that would give me 7y and negative 7y. I usually want to multiply by the smaller number because it keeps everything a little easier to manage. But it doesn't matter either way. This time I'm going to multiply by negative 2. So I get negative 2 times 5x is negative 10x. Negative 2 times y is negative 2y. And negative 2 times 9 is negative 18. So now I have negative 10x minus 2y is equal to negative 18. And the bottom one just drops down. So I have 10x minus 7y is equal to negative 18. And now I have opposite x values. So I can go ahead and add the equations. These will cancel out. I'm left with negative 2y plus negative 7y is negative 9y. And negative 18 plus negative 18 is negative 36. So now I just need to solve for the variable. So I'm going to divide both sides by negative 9. And I get y is equal to negative 36 divided by negative 9 is positive 4. So that's my y value. Now I need to plug it into one of the equations to solve for the x value. So I'll use 5x plus y is equal to 9. And I'm going to plug 4 in for y. So now this says 5x plus 4 is equal to 9. Well, now I need to solve for x. So I'm going to subtract 4 from both sides. And I get 5x is equal to 9 minus 4 is 5. Divide both sides by 5. And I get x is equal to 1. Now let's take a look at another example. This time though, we're going to notice something's a little different than the last one. So it says 5x plus 4y is equal to negative 30 and 3x minus 9y is equal to negative 18. So we begin, like always, by checking for opposite x values or y values. So 5 and 3 are not opposites and 4 and 9 are not opposites. So we're going to have to create opposite x or y values by multiplying. Now on all the previous ones, one of the coefficients was a factor of one of the other coefficients. So we were able to just multiply one of the equations. Now what we should notice though is I can't multiply 3 by anything to get 5. And I can't multiply 4 by anything to get 9. So I'm actually going to have to multiply both of the equations now. So I can pick either the x values or y values. Now the y values are going to get really large if I start multiplying by 9. So I'm going to use my x values. And I'm going to multiply the top one by negative 3. That'll give me negative 15. And the bottom one by 5, which gives me positive 15. So now we have a negative 15x and a positive 15x. And then we're going to multiply that times everything here. So negative 3 times 5x, and negative 3 times 4y, and negative 3 times negative 30. And then I'm going to do the same thing on the bottom. So 5 times 3x, and 5 times negative 9y, and 5 times negative 18. And when I do that, I end up with negative 15x minus 12y is equal to 90, and 15x minus 45y is equal to negative 90. Now notice I have opposites, so now I can go ahead and add the equations. My x's will drop out. I end up with negative 12y plus negative 45y is negative 57y. And then I have 90 and negative 90, which is 0. So I'm left with negative 57y is equal to 0. I divide both sides by negative 57 to solve for the variable, and I get y is equal to 0. Now I'm just going to plug that back into one of the equations and solve for x. So it doesn't matter, I can use any of the 4 equations now that I created. So I'm just going to use this one. So I have 3x minus 9y is equal to negative 18, but y is equal to 0. So I plug that in. Now I have 3x minus 9 times 0, which is just 0, is equal to negative 18. So this just drops out. I'm left with 3x is equal to negative 18. Divide both sides by 3, and I get x is equal to negative 18 divided by 3 is negative 6. Let's look at another example. We have 3x minus 2y is equal to 2, and 5x minus 5y is equal to 10. So again, I'm going to check for opposite x or y values. 3 and 5 are not opposites, and negative 2 and negative 5 are not opposites. So I need to create opposite values. Again, I can pick the x's or the y's, it doesn't matter. I'm going to go ahead and choose my x values. So I'm going to multiply this one by negative 5, and this one here by 3. So that gives me negative 15x and positive 15x. Now I can just go ahead and multiply. When I multiply this out, I end up with negative 15x plus 10y is equal to negative 10. And when I multiply this one out, I end up with 15x minus 15y is equal to 30. Now I have opposites, so I can just go ahead and add them. The x's cancel out, and I'm left with 10y plus negative 15y, which is negative 5y. And negative 10 plus 30 is 20. So I'm left with negative 5y is equal to 20. I'm going to solve, divide both sides by negative 5, and I get y is equal to 20 divided by negative 5 is negative 4. Then I'm going to plug that into one of the equations and solve for x. So I'll pick 3x minus 2y is equal to 2. I'm going to plug negative 4 in for y. Then we'll combine these, so we have negative 2 times negative 4 is positive 8. So we get 3x plus 8 is equal to 2. Subtract 8 from both sides. And we're left with 3x is equal to 2 minus 8 is negative 6. Divide both sides by 3, and we get x is equal to negative 6 divided by 3 is negative 2. Now there's a video here that shows you how to check systems of linear equations in Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear equations. So first thing we're going to do is go to desmos.com, which is here, and we're going to click on Graphing Calculator. Now, this allows us to type in our equations over here. So let's go ahead and put in an equation. So let's say it's y equals 2x minus 4. So there's our first equation. Now we're going to type in our second equation. So we're going to go to the line below it, and let's say it's y equals negative 2x plus 4. So there's my two lines, and if I go to where the two lines intersect and click on it, I can see that it gives me the coordinates of exactly where the two lines intersect. They intersect at x equals 2 and y equals 0. So this would be the solution to my system of equations. And I can do this by inputting any two equations and then going to the point of intersection and clicking on it. It will tell me what the coordinate of that is, with the x coordinate first and the y coordinate second. So this is how you can check your work using Desmos when dealing with systems of linear equations. Let's talk now about how to access your assignments on IXL using SBLink. So what you'll do is you'll click on the link that takes you to your SBLink, which should look like this, and you're going to log in the same way you would log into your computer. So the first part for your username is going to be the first part of your email address without the @sbcusd.ca.us. So it should be your last name, first initial, middle initial, and then the last four of your student ID. Then for your password, it's the same password you use to log into your Chromebook. From there, you'll go ahead and click Sign In. And it should take you to a page that looks kind of like this. You're going to go find the link that says IXL, which is right here. And I'm going to go ahead and click on that link. And it should take me to the IXL login page. So it should look like this. At the top right corner, it should say welcome and then your name. If it does not say your name, then you're not logged in and you won't receive credit for your work. As long as this is good, you can go ahead and close that tab out. And then you can go to your Google Classroom. And then you'll go and find the activity, which is here. And I'm going to click on the IXL link right here. And this will take me to the assignment that I need to complete. So that's how you log into your assignments on IXL using SBLink. Let's take a look now at the solving systems of equations using Elimination Part IV assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that'll take you to SBLink. This will allow you to log in so that you can access your IXL activity. Go ahead and follow that link and log in. Once you've logged in, go ahead and return to this Google form and then click on this link. And it should take you to a page that looks like this. Now, we're going to go ahead and solve using elimination. So we can see that we have negative 7x plus 3y is equal to 11 and 7x plus 2y is equal to 19. But we can already see that they have opposite coefficients. So these are going to cancel out. And we're left with 5y is equal to 30. Well, if we divide 5y into 30, so divide 30 by 5, we get y is equal to 6. And then we're going to plug 6 in for y and solve for x. And when we do that, we end up with x equals 1. So we go ahead and put that in and hit submit. It tells us we got it right and sends us on to the next one. Now the next one says negative x minus 7y is equal to negative 6 and x plus 6y is equal to 4. Well, we can see that we already have opposites here. So we just combine these and we end up with negative y is equal to negative 2. So that means positive y is equal to positive 2. And then we just plug in for y and we get x plus 6 times 2 is 12 is equal to 4. So we subtract 12 from both sides and we get negative 8. We hit submit. It tells us we got it right and our SMART score continues to go up. We're going to continue answering questions until we get a SMART score of 80. Once you get a SMART score of 80, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.